All right, Unit 9 test review. Let's get started. Number 1 right here. You obviously can't solve this right here in this current condition. So you definitely need to rewrite this as an exponent. So let's write down the conversion. So we're here right now. Log base B of A equals E. All right, with 5 being B, this being A, and 2 being E. So we need to convert it right here. So we'll have 5 squared, all right, equals 3x plus 9. And then we'll solve it from there. So you got 25. Let's subtract 9 on both sides. So minus 9 equals 3x. That's 16. And then we'll divide by 3 on both sides. And you will get, let's see, 16 divided by 3. Or 5.3. Repeating like that. Alright, let's see what we got next. Alright, so we got a natural log equation. Okay. We're going to apply e to both sides because e is the inverse of natural log. So that cancels out. And you have e to the 5th right here. And so we're going to add 6 on both sides. And then we're going to divide by -3. And x equals e to the 5th plus 6 divided by -3. And I'm going to punch that in my calculator, and I'll get -51.471. Alright, so there we go. Okay, for this one, let's start by dividing by 12. And so e to the 3x plus 2 equals 5. And so we need to get rid of this e. So we're going to apply the natural log to both sides because natural log is the inverse of e. And so now we're going to subtract 2 on both sides. And then divide by 3. And we're going to punch that in the calculator. So that'll give us a negative 0.130. Okay. Okay. Let's go to 4. So let's see. This is a natural log problem. So we got to apply our power rule for logarithms, which tells us that we can move this 3 back right here. So you have ln of x minus 5 equal to natural log of 4 cubed. Now, there's this rule, right? Well, you know what? Let's just solve it using this inverse of e. So let's apply e to both sides. So you have x minus 5 equal to 4/3, which 4 to the third, not 4/3, oh my gosh, 4 cubed. And 4 cubed is 64. Alright, so now I'm going to add 5 on both sides. And you get x equals 69. Okay? Alright, right here. Before I start, remember this right here. Property of logarithms tell me that if I'm adding 2 logs with the same base, then I can multiply the arguments. So I'm going to multiply this argument right here with this argument right here. I'm going to multiply those. So I end up with log base 5 of x times x plus 4 equals 1. So I'm going to distribute that x like that. And so now we can't solve this. Just like problem 1, we can't solve this right now. It's a lot of variables. So we're going to rewrite this as a exponent. So when we rewrite it as an exponent, you get 5 to the 1st equals x squared plus 4x. And so that's 5. And I'm going to subtract 5 on both sides. So 0 equals x squared plus 4x minus 5. And we need to factor that now. And we get x plus 5, x minus 1. And when you set that equal to 0, you set each one of those equal to 0. You get x equals -5 and x equals 1. And I can go ahead and tell you now that this is going to be the answer, because when you check it, here's the problem you run into. The problem you run into, because you got to check these, is right here. When you plug, here you go, let me show you. Log base 5 of -5 plus 4 plus log base 5 of -5. This is the problem right here. You cannot have a negative, you can't take the log of a negative argument. Alright, this is the problem. So this doesn't exist. This doesn't exist. So the answer is x equals 1. Remember that for your test. You can't have a natural log of a negative number. You also can't have a log, I don't care what the base is, we'll just put b, of a negative number. Alright, a negative x. That can't exist. Neither one of those can exist. Alright, let's keep going. Right here, let's see. Alright, so the minus tells us that we need to divide our arguments. So I'm going to divide that argument and that argument. So you end up with log base 7 of 10 divided by x minus 2. Like that. And then a couple different ways to solve this. There's a rule with our logs that tell us that if we have log base 7, we have the same log on both sides of the equal sign, we can address simply just the arguments. Like that. And so now we're going to solve that. And how we're going to do that is we need to get rid of this denominator on the left side. So we're going to do that. Multiply by x minus 2 on both sides. So you have 10 equals 23x minus 46. And so I'm going to add 46 to both sides. And you get 56 equals 23x, and then we'll divide by 23 on both sides. And so x equals 56 over 23. Alright, or if you wanted to convert that to a decimal, you get 2.435. So there's your decimal on that. Alright. Find the domain and range and end behaviors of the functions used in the graphs. Okay, so for this first one right here, I want you to see that there is an asymptote right here. Alright, this is a vertical asymptote right here. Alright, also understand, well, if we're just looking at this graph, there's also a horizontal asymptote right here. So this graph, that red line, does not cross that yellow line, which is 2, and it does not go below that green line, which is 5. So let's talk about the domain and range. Well, the domain is going to be, or excuse me, in behavior, or no, this is domain. So the domain is x is greater than or equal to -2. Well, no, it can't be greater than. Oh, I don't know why I say greater than or equal to. And negative. It's greater than 2. Alright, it's greater than 2 because it won't touch that line. It's an asymptote. And the range is going to be above the green line, so we say it's greater than 5. Y is greater than 5. Like that. Alright. Now in behavior, as x goes to infinity, or the right side, this is the right side, where's the function going? Well, as I go to the right, the function is going up. Where's the y value going? F of x means where's y going? It's going up. So we say it's going up to positive infinity. Alright, and then as x goes to the left, negative infinity, we say where's y going? Alright, so if we go to the left, travel left, what's the lowest value possible? It approaches 5. Y approaches 5. So we're going to say 5. Okay? Now let's look at this next graph real quick, number 9. Did I skip a graph? Oh, I did skip a problem. All right, let me finish this and I'll go back and do number 7. Okay, so here's the vertical asymptote again. And then here is the horizontal asymptote. Vertical at horizontal. So now if you look at this for the domain, we see that x can't pass -5. So we say x is greater than -5. And then the range can't go above 5, 6, 7. It can't go above 7. Alright, wait, is that -5? Sorry about that. 0, 1, 2, 3. It can't go above -3. So we say y is less than -3, like that. Okay. Now, the end behavior as x goes to the right. Alright. As x goes to the right, what is y doing? Alright, what is f of x, which is y doing? Y is going down, it's decreasing. Alright, y is going down, so we say it goes down to negative infinity. And as x goes to the left, how high up can it go? It can only go to -3. Alright, cool. Let's look at number 7. I gotta go back one problem, sorry about that. Alright, so without using the change of base and only using the inverse properties of, let's see, simplify the following. So log base 9 of 1 over 729. So 1 over 729, guys, is 9 to the -3rd power. Alright. If you were looking for 729, 729, that would be 9 cubed. Well, we want 1 over 729. So we're going to use 9 to the -3. Alright. So now, anyway, we're going to rewrite this as log base 9 of 9 to the -3rd power. Alright, and what happens is we substituted 1 over 729 with this right here. Put that in place right here. Substitution. So now the inverse property tells us that log and this base will cancel and I'm left with -3. Alright, we did that one. Alright, let's look at 10. 10 says find the end behavior of this function right here. So we need to graph it. That's what I'm going to do. So here's the graph right here. There's our graph. So let's talk about the end behavior as x goes to the right. Where's the graph going? It's going up. So we're going to say it's going to positive infinity. And as x goes to the left, it's going down to right here, -4. Alright, so as it goes to the left, it goes to -4. So let's look at that. So again, as x goes to the right, alright, the graph is going up to infinity. Alright, y is going up. And as x goes to the left, alright, the function is approaching -4. Alright, that's that horizontal asymptote right there. Now for this next graph right here, find the end behavior of this function. So this is the graph right here for y with 1/3 x plus 1, 1/3 times the square root of x plus 1. Alright, so as x goes to the right, it approaches positive infinity. And as x goes to the left, it approaches 0. Alright, 0. Y is 0 is the asymptote here. So as it went to the right, it approached infinity. And as it went to the left, it approached 0. Where's my mouse? There it goes. 0. Alright, let's keep going. Alright, for this next problem, y equals 7 minus the square root of x plus 2. Here's the graph. and it's in behavior again. So as x goes to the right, it goes down to negative infinity, and as x goes to the left, as I travel this way, I'm traveling up to 7. That's as high as we can go. So again, that graph looks like this, right? So as x goes to infinity, to the right, the function is going down to negative infinity, and as x goes to the left, remember it went up to 7. All right, that's as high as the function can go. All right, now for this next problem, it says find the inverse of the function right here. So we got to find the inverse. So remember, you start by swapping x and y. So to solve this, we need to go and convert this to a log. All right, so log base 3 of x equals y minus 2. And then we're going to add 2 to the other side. So plus 2. We're going to add 2 over here. So you end up with log base 3 of x plus 2 equals y. That's your inverse right there. 14, find the inverse of this function. Again, we're going to start by swapping x and y. Not equals 1, plus 1. Sorry about that. So plus 1, 5 to the y plus 1. Then we'll subtract 1 on both sides. So x minus 1 equals 5y. And then we're going to rewrite this as a log. So log base 5 of x minus 1 equals y. That's our inverse right there. Okay. All right. So right here it says Elijah wants a new iPhone 12 Pro that costs $999. The phone will depreciate at a rate of 11% per year. Write an equation and find the value of the phone after 3 years. Okay. So what you have here is, and this goes back to the beginning of the unit where a equals p times 1 plus or minus r raised to the t. All right, so in this case, p is the original 999. Then we got 1 minus 0.11, 11% converted to an r raised to 3 years right there. So we punch that in right there, and we get $704.26, like that. All right, evaluate without using the change of base formula. So right here, this base 5 raised to log base 5 cancels out, so it's 31. And then right here, we need to rewrite this log 8 of 4,096, okay? Side note, 4,096 is going to be 8 to the 4th power. So we're going to rewrite that as 8 to the 4th power right here. And so that log base 8 and this base 8 to the 4th cancels, and I'm left with 4. All right, and 31 minus 4 is going to be 27. All right, for this problem here, it says evaluate using the change of base formula and round to the nearest hundredth. So using the change of base formula, that means we need to write this as log of the argument divided by log of the base. All right, and we'll punch that in the calculator. And when you punch that in the calculator, you get 2.125. Now, for number 18, it says find the inverse. So again, switch x and y. Like that. And so we're going to add 1. So now what you want to do is we need to get rid of the natural log. So we're going to apply e to both sides because that's the inverse of natural log. So you have e to the x plus 1 equals 9y minus 7. And so we add 7 on both sides. So that's e to the x plus 1 plus 7 equals 9y. And then we'll divide by 9 on both sides. And we can conclude that y equals e to the x plus 1 plus 7 divided by 9. And that is the inverse. Alright, so x equals, so we're going to first start by subtracting 6 on both sides. Ooh, sorry y'all, that should be a 9 right there. I mean a y. There we go. So subtract 6. And so we're going to divide by 9 on both sides. So now we need to get rid of the e here. So we're going to, the inverse of e is natural log. So we're going to natural log both sides. So we have natural log of x minus 6 divided by 9 equals x, y minus 1. Sorry, I rewrote this right here. There you go. And so we're going to add 1 on both sides, so plus 1. So we have natural log of x minus 6 over 9 plus 1 equals y, right there. Like that, okay? And that is number 19. How long does it take for an investment to double at an annual interest rate of 7.25% compounded continuously? Excuse me. So A equals PER raised to the RT. All right. So we're trying to double this amount. So we're going to let A equal 2P because P is what we're putting in. We want to double that. So 2P equals PE raised to the RT. But we know what R is as well. Sorry about that. R is 7.25, so 0.0725. And we got to find T. So how we do that is we start by dividing by P on both sides. So you get 2 equals E raised to 0.0725T. And so to get rid of this E, we need to take the natural log of both sides. So you have natural log of 2 equals 0.0725T. And now all you got to do is divide by 0.0725. And you get T equals, let me punch that in real quick, 9.5 years. All right. And then our last problem on the now, Thomas invests $5,500 into an account that pays 7.25% interest per year. After how many years will the account be worth $11,000? So we want the account to equal $11,000. Oops, sorry about that. E raised to the R. T. So we're looking for time again. So we're going to start by dividing by 5,500. So I'm going to leave that like this for this time right here. And so again, we need to get rid of E here. So we're going to apply the natural log to both sides. So 0.0728 equals natural log of T. And so now we're going to divide this out. And I like to just continue working the whole problem. So you get T equals, and I'm going to punch this into my calculator. So when I do that, you get natural log. Make sure you put parentheses around this when you punch it in. And you get 9.52 years, like that. All right. Okay. Hope this video helps, and good luck on your tests.